Hello all. In this lesson we are going to take one look back at phase changes, but we will add in a new lens for understanding. And that lens is going to be that we will talk about their arrangements and their amounts of potential energy. And we'll also add in another phase change, which is sublimation, and its cousin, deposition. There is a quiz associated with this lesson, and I want you to make sure you have this aim copied down along with the do now on a separate piece of paper, which you'll title classwork for this lesson. All right, so let's start the mini lesson. What happens to ice cubes that have been in the freezer for too long? I'm not sure if you have noticed this, but I very rarely use ice, but I insist on having my ice cube trays full to the top. But what I've noticed is after a few months, the ice trays start to become maybe half full, and it's very noticeable that the ice cubes have been shrinking over time in the freezer. The reason why that happens is due to a process called sublimation. And sublimation is the process by which particles in a solid spontaneously change to gases, and I will have a diagram shown here. So I included a diagram, but in short, sublimation is the phase change directly from solid to gas. And my diagram is over here. I'm going to zoom in just a little bit for you guys. So basically what I showed was a regular geometric pattern that represents solid in a particle diagram. And then throughout the process of sublimation, the particles of solid will spontaneously change to a vapor or particle diagram arrangement. And this is actually based on randomness. We know that temperature is a measurement of the average kinetic energy, and inside your freezer, the average kinetic energy obviously never rises above 0 Celsius, or everything in your freezer would melt. However, average kinetic energy does not say anything about one individual particle's individual energy. So that means that individual particles can individually and randomly gain enough energy that they'll break their solid arrangement and go to a vapor arrangement. So average kinetic energy is not the same thing as individual kinetic energy, and even though the entire substance may have an average kinetic energy of less than 0, an individual particle can have an energy more than that and can become a vapor. And that process over a long period of time can result in a noticeable loss of solid to the vapor state. And that process is called sublimation. So I'll zoom back out here, and we will talk about what happens to the walls of the freezer over time. You may have noticed that the walls of the freezer can collect the vapor that was being produced in the previous idea. That vapor that's being produced can collect on the sides of the freezer and turn back into a solid. That process is called deposition, and deposition is defined as the spontaneous change from the gaseous state to the solid state. And similar to sublimation, it is a gradual process, but it's also spontaneous. And basically those individual particles that had randomly gained enough energy to sublime, they will hit the wall of the freezer, which is very cold, and they'll immediately lose all of their kinetic energy, and they will drop back into the solid state. And over time, that can build up as frost on the insides of the freezer. So I will zoom back out here, and in this part where you need to copy down this table, and we need to match up the names of phase changes with column B, which is the description of the phase change. I'll start you out with 1. And evaporation. Evaporation is the change from liquid to gas, which means that it matches up with F. And condensation is the change from gas to liquid, So that matches up with D. Vaporization is the change from liquid to gas, and that matches up with F. And this is interesting because F is appearing twice now. So that means that evaporation and vaporization are similar processes. Sublimation, as we've learned, is the change from solid to gas. So that'll be E. Melting is the change from solid to liquid, and that would be change C. Deposition is the change from gas to solid, or B. Freezing is the change from liquid to solid, which would be A. And fusion is either the change from liquid to solid or solid to liquid. So I'm going to say it's either A or C. And in both cases, we've already used A and C, so I'm just going to point out that you can use fusion interchangeably with melting or freezing. Okay, and in part 2, we need to discuss the types of energy that we're going to see. You might remember that potential energy is the energy of position. It's stored in the distance between particles, and the more distance particles have between them, the more potential energy they'll have. Therefore, gases have the most potential energy. When you're looking for it on a heating or cooling curve, however, you won't really see it directly, but you could imply its existence in those flat areas of the heating curves and cooling curves. That's when potential energy is changing. And kinetic energy is the energy of motion. It's often thought of as analogous to temperature. And on heating and cooling curves, you'll see it on the temperature axis, which is the y-axis. But heat energy actually includes both potential energy and kinetic energy. So when substances are being heated over time, you will see changes in potential energy alternate with changes in kinetic energy. But throughout that entire period, heat energy is being absorbed. So that's why we generalize the term heat to mean all the kinds of potential and kinetic energy. Where you'll find it on the heating cooling curve is, in a way, the x-axis, because the x-axis is showing you that heat is being applied constantly over time. So the term exothermic is meaning energy is being released, and you can remember this term because exo sounds like exit. And the term endothermic means that energy is being absorbed, and you can remember that because en or n sounds like enter or in. And you've done it. We finished the lecture. All you need to do is copy down this table under pair up, which will be underneath the do now and the aim for the classwork section of this notes. And also copy down the summary. So yeah, copy down pair up and summary and you'll be all done. Thanks for watching.